Hey everyone, welcome back to the channel with today's LeetCode DCC question, minimum common value. Let's look at the problem statement. Given two integer arrays, nums1 and nums2, sorted in non-decreasing order. So this point is important. Return the minimum integer common to both arrays. If there is no common integer amongst num1s and nums2, return -1. So what problem statement is saying? So we'll be given two integer array. Suppose this is num1s and this is nums2. And let's suppose there are some common elements. So this is common to this element and this is common to this element. So if we have any of the common elements, we have to return the smallest of the smallest common elements. If there is no common elements, in that case, we have to return -1. If we see, the point they have given is that the arrays are sorted in non-decreasing order. That means out of all the commas, the first one will be the smallest common since the arrays are in sorted order. Solve this question, there are many approaches. Let's look at method 1. Suppose we have two arrays and the numbers are 2, 3, 4, 5, 6, 7, 8, 9, 9, 10. Suppose these are the elements nums1, nums2. Now let's keep one pointer for nums1 and another pointer for nums2. If we compare both the elements 2 and 3, let's see whether 2 is present in this array or not. If we see the first element in nums2 is 3, that means, can we say 2 is not present in nums2? Because if 2 were in the array, then it must have come before 3. And since the first element is 3, we can for sure say that 2 is not present in nums2. Let's talk about 3 in nums1, whether 3 is present in nums1 or not. Since the current element is 2, there is a possibility that if we go rightwards, we might find 3 in the array. So we will increment the pointer, which is the smallest element. So since 2 was the smallest out of 2 and 3, we will increment the pointer of nums1. Now let's compare again. Now the elements are 4 and 3. Let's see whether 3 is present in nums1 or not. Since the current element is 4, we can for sure say that 3 is not present in nums1. Because if 3 were in the array, it must have come before 4 and after 2. But after 2, the next element we found was 4. That means 3 is not present in the array. And if we go rightwards also, we will not find 3. Because since the array is sorted, we will find the numbers greater than 4 or equal to 4. So we can for sure say that 3 is not in the array. So there is no use of 3 and we don't need to search 3 again. So we will increment the pointer, which is smallest. If we would have seen for 4 with compare with 3, there is a possibility that if we move rightwards of 3, we might find 4. That means, suppose for pointer 1, there is a element pointed by pointer 1 and pointer 2. This is present in nums1, this is present in nums2. We will compare if both the elements are equal. That means that is the smallest element, smallest common element. Else, we will shift the pointer to right side of the array, which is smaller, which is small. If we see for case of 2 and 3, we shifted the pointer of 2 right side. And now in case of 3 and 4, we shifted the pointer of 3 right side. So if the elements are same, then we can return that element as the smallest common. Else we will shift the pointer of the smallest element to its right side. If we look at this examples, the examples are 1, 2, and 3, and 2 and 4. If we keep the pointer here and here, if we compare 1 and 2, 1 and 2 are not same. So is there a possibility that we will find 1 in the array 2? No, right? Because if 1 were in the array 2, that means it would have come before 2. So since the first element is 2, we cannot find 1 in the array 2. So there is no possibility of 1 to be the smallest common. So we will shift the pointer of 1 towards its right. Now again we will compare. Since the elements are common, since the 2 is equivalent to 2, so we will return this element because this is the first element which we find it common, which is common. If we move rightwards of both the elements, there is a possibility that we will find the elements common again, but that will not be the smallest one. So for the first element which we found to be common in both, that will be the smallest one. So in this case, we can see the answer is 2. Now take another example. 1, 2, 3, 6, 2, 3, 4, 5. If we see in this example, nums1 pointer is pointing at 1, nums2 pointer is pointing at 2. Since both the elements are not common, so we will shift the pointer of the smallest element towards its right. Now we will see both the elements are common. That means this is the first element which is common in both the array. If we move the pointer towards right of both the array, we can see again there is one common element, that is 3. But we have to return the smallest. So the 2 will be the smallest element. So the first occurrence of the smallest is the only smallest. First occurrence of common elements will be the smallest. If we see another approach, this is method 1. So if we talk about time complexity in this, time complexity is in the worst case, we will traverse both the array. Let's suppose the size of array 1 is m and array 2 is n. So there is a possibility that we reach the end of the array 1 and end of the array 2, and we found that there are no common elements. In that case, the time complexity will be big O of m plus n, and the space complexity is constant since we are not using any extra space. Now let's look at method 2. If we look at method 2 with taking same example, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So another method can be of hash map. Suppose we store the elements of one array in a map. Let's suppose there is a presence of 2, there is a presence of 1, there is a presence of 6, there is a presence of 9, there is a presence of 10. So we store the elements of any one of the array in a hash map. In O1 time, we can check whether now we will iterate. Now we will iterate the elements of another array. Suppose we have pushed the elements of nums1 in the hash map. Now we will iterate the elements of nums2 one by one, starting from the beginning. Now 3. If 3 is present in the hash map, that means 3 is the smallest element which is common in both. Since the arrays are sorted in increasing order, if any of the element we found, first element we found common, that means that is the only smallest. So we will see 3 is not present in the hash map. So we will move with the pointer to next one. Now we will look for 5. Again, we will see 5 is also not present in the hash map. Now we will move the pointer towards the right. Now we will look for 7. Again, we will see 7 is not present in the array, in the hash map. Now we will move for 8. Again, we see 8 is also not present. We move to 9. We will see, yes, 9 is present in the hash map. That means 9 is the smallest element that is common in both. So we will return 9. If we see, to push the elements in the hash map, we took big O of n space and it took big O of n time also. And to iterate the elements one by one and look in the hash map, it took big O of m time. And to search in the hash map, again it took big O of 1 time. So overall, we can see the time complexity for this approach will be big O of m plus n, and space complexity will be big O of n. So if we see nums1 and nums2, we can store the elements of either nums1 and nums2. If we are worried about space, then we will store the elements of the smallest array. If the array size of nums1 is 4 and nums2 is 100, then obviously it is better we push the elements of size which has 4. In that case, we will get the smallest time space complexity. Now let's look at method 3. So this was method 2. Now let's look at method 3. Since both the arrays are sorted, right? So can we use binary search in this? Now let's take same example again. Suppose we have 2, 3, 4, 5, 6, 6, 7, 9, 9, and 10. Now, suppose we traverse one of the array. Suppose we are traversing this array one by one. Suppose we are at 3. Now we will do a binary search of 3 in this array. Since this array is sorted, we can easily do a binary search, which will take big O of log n time if the array size is n. If the array size is n. Now we will do a binary search of 3. We will see whether 3 is present in the array or not. So it will return false since the 3 is not present in the array. Now we will move one element right and we will see whether 5 is present in the array. Again, we will do a binary search in this array. Binary search in the array. Again, it will return false since the 5 is not present in the array. Now we will check for 6. Now the binary search will return true since 6 is present in the array. So we will return 6 because 6 is the first element which we found to be common in both the array. So in this way also we can find the smallest common. So for this, if we see the time complexity, if we iterate the smallest one, so we will get big O of n and log of m times. If the array size of the array in which we are doing the binary search is m, then it will take log m time. And if we are traversing the array which has size n, then it will take n into log m times. And if we talk about space complexity, we are not taking any of the space, so it will take constant space. Now let's try to code all the 3 methods one by one quickly. Now first we will implement method 1. For method 1, we will calculate the length of both the array, that is nums1. Now we will initialize the pointer for both the array. If nums1 of I is equal to nums2 of j, that means this is the first smallest element we found and we will return this element straight away. Else, we will compare which pointer we need to shift. For that, we will compare if nums. So since the nums2 element is smaller, we will increment the pointer of nums2. Else, we will increment the pointer of nums1. And if there are no common elements, then we will return -1. Let's try to run the test cases. Test cases has been accepted. Now let's try to submit. So the solution is accepted. Now let's try to do code method 2. In this, we will use hash map. For that, we will create a map. Suppose we are iterating nums1 now. And we will push nums1 in the map. Now again, we will iterate nums2 and check one by one whether that element is present in the hash map or not. So if ump.find it equal to is not equal to ump.end, that means this is the smallest element we found, so we will return it. And if we don't find any of the common elements, in that case, we will return -1. Now let's try to submit the solution. So we can see the solution is accepted. Now let's try to code method 3. We will use binary search approach. So what we will do, we will iterate the elements of any of the array. Let's suppose nums1. And we will do a binary search of that element in array 2. Let's suppose the pointer returned by binary search will be it1. So we'll do a lower bound in nums2. It. If it1 is not equal to nums2 dot end and star of it1 equal to it, in that case we will return it, else we will return -1. Let's try to run the test cases. Okay. Now let's try to submit the solution. So we have tried the coding all the three methods. So I hope the problem statement and solution is clear. So this hash map and binary search method is very helpful if the arrays givens are not sorted. So in that case, we can use this approach and it will not take much time. So if you have any questions or any doubts, mention in the comments below. See you in the next video. Thank you.